come all to this tragic affair. Wipe off that makeup, what sinister spare. So throw on the black dress, mixing with the light. You might wake up and notice you're someone you're not. If you look in the mirror and don't like what you see, you can find out firsthand what it's like to be me. So gather round, piggies, and kiss this goodbye. I'd encourage your smiles, I'd expect you all cry. Another contusion, my funeral drag. Here's my resignation, I'll serve it in drag. You've got front row seats to the penitent's bar. When I grow up, I want to be living out loud. I said, yeah, yeah, yeah. I said, yeah, yeah, yeah. Come on, said save me. Shot in the heart and save me. Too young to die and you can't live and can't hear me. Save me. And if your heart stops beating, I'll be here wondering, did you get what you deserve? The ending of your life, and if you get to heaven, I'll be here waiting, babe. Did you get what you deserve? The ending, if your life won't wait, then your heart can't take it half. You heard the news that you're dead. No one ever had much nice to say, but I think they never liked you anyway. Oh, take me from the hospital bed. Wouldn't it be grand to wouldn't it be grand if it was exactly what you're planning? Wouldn't it be great if we were dead? Oh, dead. Tongue-tied and oh so squeamish, you never fell in love. Did you get what you deserve? The ending of your life, and if you get to heaven, I'll be here waiting, babe. Did you get what you deserve? The ending of your life won't wait, then your heart can't take it half. You heard the news that you're dead. No one ever had much nice to say, but I think they never liked you anyway. Oh, take me from the hospital bed. Wouldn't it be grand to take a pistol by the hand? And wouldn't it be great if we were dead? And my honest observation during this operation found a complication in your heart so long. 'Cause now maybe just 2 weeks to live. Listen, nothing both of you can give. One, two, three, four, la 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 la. I'm a motherfucker, la 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 la. Oh motherfucker, life ain't just a joke. Then why are we laughing? Ain't just a joke. Then why are we laughing? Ain't just a joke. Then why are we laughing? Ain't just a joke. Then why am I dead? Dead. Hello everyone. So today we have Jeffrey running here. Over on the side you can see he's kind of spazzing out and flashing his flashlight whenever he feels like it. This is because there, once again, has not been much progress in terms of learning in this current running. Now, I am continuing to run this simply because this is the only running I have available at the moment. This is the running with the optimizer in it, although I have gone over the fact that I believe the optimizer does not necessarily work. Even if the code is sound, it does not necessarily create an improvement to the program, but it doesn't seem to be harming anything, so I'm continuing to run it. So you can see that he is still dying here and not necessarily being able to locate any food. So this is definitely a problem, and I believe I have the solution in the works. Now, this is what I've been talking about over the past couple weeks. This is the new engineer program. Now, this engineer program could be considered a second tier, per se, to this entire AI as a whole. So that was a bit redundant. I have started work on this, and I wanted to just kind of get on the stream and brainstorm a little bit, because I was actually working on this literally minutes before I started the stream. So what I want to talk about is the way that the engineer program will create new tools for the AI to work with. And so the idea, and I've talked about it a little bit in the past, is to have a top-down mentality. And with that, the AI will be able to assign a task that it wants the engineer program to figure out how to achieve. And much like how the program that's running on the side has a overarching task where it's trying to get this score to go up, and by going up, surviving in the process, this engineer program will create tiny tasks and break up the larger task at hand into a smaller, reasonably capable chunk of that. It's a smaller task that the AI that I have created can attack and find a solution to, so that when it adds all of the answers of those smaller tasks together, it can get a larger answer for the overarching task. So this is something I have recently started working on, and like I've explained in the past, some of the logistics of it, but I have actually started the coding process, so now I have a little bit more insight on what the actual coding task is. So my first thing I'd like to mention is that I plan to do this recursively. So this almost inherently takes in this top-down mentality. So what it will do is it will say, so the skeleton and the outline I've been starting to work around in my head is to have this program run through, and it's going to look at a chunk of time. And this chunk of time, I might have mentioned this before. So this chunk of time is 100 ticks, and 100 ticks isn't that much time. Actually, the AI's health goes down every 100 ticks, I believe. So in that tiny chunk of time, it looks and it sees if anything has changed. So and it's not a constant, like, it'll look at this 100 ticks and then it'll look at this 100 ticks and then this 100 ticks. It's the driver program here. The driver program that we have running is constantly keeping a chunk of 100 available, but it's a continuous process. So whenever the engineer program goes in and tries to look at that chunk, the driver will have that available, the most recent 100 ticks. So that is that's the input of the driver program, and this is similar to the boss sample that I've talked about. The boss sample being a snapshot of the environment. Well, this is sort of like 100 snapshots of every variable that it has to look at. Some of these variables are input variables, some of these variables are output variables, but this is what we're working with. So once it has looked at this chunk of time, it then has to analyze what has happened in that chunk of time. So what I mean by that is I had to sort of formulate what specific things and changes in variables could be considered events. And by events, I mean something significant that the AI needs to look at so that it can learn how to recreate said event. And so right now, and this may change, I may add more, I may take some off. Right now there are two different types of events. The first event is an acceleration. So I figured since the health goes down constantly, and in a given situation the battery could be going down constantly, and there are many things that could be a constant change. The AI needs to know. The AI doesn't necessarily need to consider these constant changes because they are not. It's something that's happening constantly. So it's not a significant event. Now let's say. So what I mean by accelerations is when the slope of change changes. So let's say that Jeffrey here is moving at a constant rate in a random direction, and then he runs into something. Well, then after he runs into that whatever he ran into, then he will stop. So even though he's trying to push forward, he will stop. And so in that chunk of time, you will see that there's a constant slope, and then it drops. So the slope could be at like 1. So let's say he's going 1 pixel per tick, and then suddenly he's going 0. And so that's a significant event because something has happened, and I'm hoping that this will allow the AI to understand associations between things like when Jeffrey runs into things, because in the current runnings, the AI has not been able to establish those associations. Jeffrey will do the same thing whether or not there is a rock in front of him or not. That's the first event, and the second event is if any variable becomes equal to another variable. So not if any variable is equal to another variable, because an event requires change. Something has to happen to cause this. So what the engineer program is analyzing is or at least pinpointing is what things are significant that have some sort of cause that would have caused them to happen. So what I will do from there is, or what the program will do, is it will take those events that it has pinpointed and then start to do some testing on those events. So from there, I have a function that I'm writing that will it will start with the significant variable. So whatever variable was the variable in question for this event, it will start with that variable, and then look at the and then so what I'm trying to get it to do is to recreate these events. And in doing so, now the actual process of doing this will be somewhat recreational, because this won't necessarily, unless it's trying to recreate a change in score, it won't necessarily make the AI better at playing the game. But the process is what's important, because, and I'll get to it in a bit. I'll get to the specifics in a bit, but in order to recreate these events, the AI has to create a bunch of tools in order to recreate those events. And then at that point, those tools are forever at its disposal. So if the driver says, okay, I need to increase my health, then it can go look at this toolbox and say, this specific tool raises my health with little to no repercussions. I'll use that. And then instead of doing the random thing that the instinct has figured out, it will override that with this thought out tool that is at least mostly successful. And so, like I said, I will get into more specifics. So at this point in the outline, we are at the pinpoint stage. So it has pinpointed all of the specific events that have happened, and then it goes into this function. So this function, the function will take in a specific event. It won't look at all of them. It will eventually look at all of them, but at any given time that the AI goes into the function, or in any given time that the program goes into the function, it will be looking at one specific event. So it'll say, let's say, the score changed, because that's an important one. So if it looks and it says it'll say the score changed, and it went up or down or something like that. So then it will, and this has to be a significant change. It can't just be a constant change like how the health changes it. So the AI will look at this variable, and then it will take in the rest of the variables and look at which variables changed even constantly in order, like at the moment that this variable in question changed. So now it will also have to consider if the variable in question is a output variable. Because if it's an output variable, that's not a problem. It can change that whenever it wants. So say this is the variable for moving, the variable for shooting, the variable for flashlight or something like that, then it will immediately quit, says, okay, I know how to do that. Just, it will, okay, I'm probably going to have it so it writes a tool in order to change that variable. But this will be a one-step process. No recursion will occur. And so it'll go through and it'll read, it'll say, okay, move changed to 1 instead of 3. So write a tool for changing move to 1, which will be extremely simple. It'll just say move equals 1 and then move on. So then after that, but if this is an input variable, so this is a sensory data, this is either like score, health, X variable, Y variable, something like that. It will then it'll say, I can't directly change this. So what variables can I change in order to indirectly change this in the way that I would like to? So it will then scan through, and like I said, it will scan through all of the variables that change in any way between the tick before the event and the tick at the event. So it will look at just a even smaller chunk of time, just 2 ticks, so 2 instances of time, and it'll say what changed. So then once it's figured out all of the variables that change, then it needs to start the process of figuring out which changes were important in order to create this effect. So what I'm planning for it to do is to set up a simulation of the environment at the instance just before the variable in question changed. And then it will take all of the variables that change and go through and change starting with just changing one variable, it will change each individual variable that changed without changing the others, and see if that affects the output or the outcome. So let's say um, the score went up, and so it will look at the let's say also move changed, which would be weird if move was changing at a constant rate, but we'll ignore that. Um, so move changed from 1 to 2. So and then there are a bunch of other variables that changed. It will ignore all of the other variables that changed and switch move from 1 to 2 and see if the score goes up. If the score does go up, then it'll say, "Hey, we figured it out right off the bat." And it will skip, go on to the next event. But if it doesn't, it'll keep scanning through each individual change, and then if it doesn't find anything from an individual change, because that would be the easiest thing, then it will move on to combinations of 2, and it will move on to combinations of 3. And this also is requiring that so it can only go up to as many changes as there were. So if there's 7 variables that changed in the time that the variable in question changed, excluding the variable in question, obviously, because if the variable changes, then the variable changes, and that doesn't really tell us anything. So if 7 variables change, then there's a possibility that all 7 changes were necessary in order to get this outcome. So it will continue to finagle with these different combinations of changes until it finds one that works. And then it will spit that out, say, these are the changes that need to happen. Now, what will happen at that point is it will look at those changes that need to happen and say, can I do those directly? So if all of the changes that need to happen are output variables, if they're the moving variable, the light variable, the sprint variable, something like that, then it will just write a function, like I said with the previous situation, in order to change all of those at once. But if any of them are indirect variables, if they are sensory input variables, then it will call itself in order to find a function that will or find a macro that will change that indirect variable specifically. So then that's the situation. So then it needs to find a total list of directly controlled variables that it can change in that specific combination in order to get the outcome in question. But along the way, it will create a bunch of different functions that will create. It'll just create this entire toolbox of functions that later, when it says I need to change this variable, it can scan through and see if it's already created such a tool. So the engineer program isn't necessarily looking at what's happening specifically with the driver. So it is a little bit. So this is a little bit more of a close relationship than the boss and the parent program and whatnot, between the driver and the AI. So the AI will be looking at a given chunk of time what is exactly happening in the real-time game. And so then once this total function is created, it will pop out and go to the next event, do the same thing. But once it has analyzed all of the events, then some more things will happen in the in-between stages, or between restarting the cycle and the end of analyzing the events. So the AI will need to test the statistics of these new tools. So it will have to set up random environments and things like this, and test how successful it is, so it can record the statistics of this new tool that it has created, because it wants to know how successful the tool is. So let's say the tool in a given random environment works 60% of the time. This isn't the best, but it's better than something that only works 40% of the time. So this will come into play when the driver goes looking for what tool it wants to use at a given moment. It will be able to scan through a list of statistics, and it's almost like a resume for the tool. So all the tools supposedly want to be used, but the driver is only going to use the best tool. So it will look at the statistics and it'll say this tool works 60% of the time given a factor of some standard deviation. And but that's not the entire complexity. So that will be for all random possible environments, but then it will need to also find ideal environments. So what it will do is it will go through and try to find the like best case environment that it can use, and find how much wiggle room it has with that environment, so that the driver can go through and say, am I in an environment where this will be successful? Because obviously if the driver is in an environment where it is in the specific environment it won't work, it doesn't want to use that tool. So it will first look at which tools are okay in its given environment that it's in, and then if it can't find one that's good for its specific environment, it will go to the next step and say, okay, what usually works? And that's when it will look at this statistic of a given random environment. So these statistics will not just be written by the engineer program. These will also be updated by the driver program, because obviously it's the driver program's running of the task that's the most important. So the driver will pick out a tool through the algorithm that I'm going to write in order for it to scan through the toolbox and find the best tool for the situation. And then, but it could be that there isn't a lot of data on this tool. So there's just the initial data from the engineer program, which may be a little biased or whatnot. So the driver will update this data based off of whether it successfully worked for it when it applied it in the actual game. And so then from there it will be able to hone in on the statistic, so that later when it comes back it has a more accurate representation of all of its tools. So there's also an aspect I want to add into the driver program. So currently the driver program is scanning its current environment, and it will I may have talked about this a little bit previously, but it's going to in a sort of Maslow's hierarchy of needs sense, decide whether it feels safe and whether it feels comfortable. So those are just words I've chosen, but safety is meaning is its health in a situation that it doesn't need to immediately go get more health, and is its battery in a situation where it doesn't need more battery, and like it will last long enough for it to be able to go get battery later. So I've decided that these values are considered its confidence. So this confidence isn't necessarily a set in stone value. This confidence is something that the engineer will update as it creates better tools. So at the start, it will have no confidence. There will be no tools, so it has absolutely no chance of successfully getting a food pellet and whatnot. But as the driver creates things that have an outcome of the health increasing, then it will be able to analyze and say, okay, this is the best this is the best tool I have to work with to get this outcome. And then from there it will say how much health and battery is normally lost when I use this tool before I get the benefit. So it will look at the maximum net health lost and the maximum net battery lost, and it will say, and that will be the confidence value. And I might add some buffer in there just so it can, or something to do with standard deviation, so that it is a more accurate variable of, so it's more of like a 100% thing that it will be able to successfully do that. Now, as it creates tools that are more efficient in carrying out the task, it will be able to adjust those confidence variables so that it doesn't necessarily need to go get food immediately. It can do whatever it's doing, and whatever it's doing will be testing these new tools. Because, like I said, it needs to test these tools in the actual game so that it is getting an accurate statistic on whether these tools are successful. So there will be somewhat of a priority list, much like the priority list that I have set up for the parent program. Now, the parent program looks at the most prioritized snapshot environments and works on the instincts for the most prioritized environment, as said by the boss program. The boss program updates this priority list. But there will be a sort of a priority list for the tools that need to be tested. And so then the driver will look at this priority list once it feels safe and comfortable, and it will say, okay, I need to test this tool. Am I in an environment to test this tool? And if it is, it will test that tool. If it's not, it'll move down the list and say, which one am I in an environment for? Once it finds one it's an environment for, it will test that tool, update the statistics, and whatnot. So now these tests will be run over 100 ticks. So it will have to it will have to see if it will have to, the tools will have to be designed to be successful in 100 ticks. So let's say it was trying to find a piece of food, then its ideal environment would be within 100 pixels of that piece of food, because it needs to move to that piece of food. Or it could sprint there and it would be quicker, but it would waste some battery. But these are all speculations, because the engineer program will have to find all of the, or figure out all of these things on its own. So the tiers of the hierarchy is, it will first check to see if its health is above the confidence level. Then it will check to see if its battery is above its confidence level. Then it will go on and say, is there anything I need to test? And if there's nothing it needs to test, then it will just do whatever its instincts tell it to. And whatever its instincts tell it to may put it in a new situation that it has not seen before. So then the engineer can now create new tools in order to accommodate this new situation. So it's an endless cycle, and in the beginning, the engineer will not have any tools, but by the end of it, the engineer will have enough tools to where Jeffrey here will not necessarily need to use his instincts at any point in time. I was considering, and I forgot to mention that, having a fourth tier after it says, okay, there's nothing I need to test right now, then it will just do whatever has the highest score output. Because that is the general goal of the entire game, is to get the highest score possible. Once it feels comfortable and everything, then it will just do whatever random thing has the highest output of score. And so that will overrule the instincts in the late game. But yeah, so this is the entire outline of what I wanted to talk about. So I don't know if anyone has any questions. I'll stick around for a bit. I know I was talking pretty quickly there, but I wanted to make sure that I was thorough. So I'll just give a quick summary while I'm waiting to see if there's any questions. So the program will be working recursively. It will scan through, say, what changed. Then it will look at that change and say what things might have caused this change. Then it will test those things that might have caused the change in order to find which specific changes in variables caused the change in question. And then it will write a function in order to enact those changes, so that it can get the desired outcome that it's looking for. And that's the general summary of what I'm working on right now. And then after that, it will test the new functions that it has created and provide statistics in order for the driver program to be able to look at those statistics, scan through, and find the ideal tool that it is looking for a given situation. So, like I said, that's the general idea of the outline. I'm not seeing any questions in the comments, so I will be probably signing off here in a second. I wanted to give you guys a heads up, though, that I will not be streaming this weekend. I have an event I'm going to, but I'm sorry that I didn't get to stream this Saturday, or this last Saturday. I was feeling pretty tired, and I figure with this channel, I don't necessarily want to force myself to follow the schedule if I am not feeling up to making quality content for the stream. I had some ideas of what I might have talked about, but I wasn't necessarily certain. And in the past, when I've tried to stream while I'm tired, it's just sort of me droning monotonely. So I don't really feel like that's what I want this channel to be. I want this channel to be energetic. I want it to be a community. Now, I can provide the energy, but I need an audience to provide the community and to provide the constant questioning. So I'm not this oracle of knowledge. I'm also learning in the process. I want people to ask questions so that I have to push myself in how I'm analyzing the situation, and also so that the other people watching are getting a more credible pool of information. Because me just being a college student, I'm not necessarily the most credible source. Now I do I would put myself slightly above the average in terms of credibility, but this is something that I want to build over time. So I'm trying to get a community of people here together so that the overall knowledge of the community can improve, not just mine and not just a specific person. So that being said, I do think that I will be signing off here. I'm not seeing any questions, like I said. So I want to thank you guys for watching, and I will be seeing you guys next Wednesday, barring any random changes or me feeling the random urge to stream at any other point in time. But with finals this week, I probably will not be doing that, so I wouldn't keep your hopes up. But I will try to stream on Wednesday, so I will be seeing you guys in a week. Thanks for watching.